Hey guys, this is going to be a video on the 3.3 homework. So in class we've learned how to divide polynomials using long division and synthetic division. But let me go through these and help you out if you need any. To set up using the long division method, we are going to write out the dividend, which is x squared plus x minus 17, and then the divisor, which is x minus 4. So the dividend goes here, the divisor goes here. Okay, and then we're going to divide. It really follows a very similar process as regular long division if you were using numerical values rather than polynomials. Follows the same kind of concept, or I guess you can say the same kind of steps. But so first of all, we are going to see, we're going to take the first term of each, the divisor and the dividend, and we're going to see how many times the first term in the divisor can go into the first term of the dividend. So how many times can x go into x squared? Or another way you can look at it is, what do I need to multiply this by to get x squared? And you can always just, off to the side, if just using some scratch area, take the first term of the dividend, divide it by the first term of the divisor, and well, that's just x squared divided by x is going to be x. And so that's how many times it can go into it. So we're going to go ahead and put x then up on the first term of our quotient. Remember that we have the dividend, divisor, and the quotient is the answer. So we're trying to find the quotient. But in any case, so we took the dividend and we took the divisor. We just divided those to get x, and that's what we know is going to be the first term of our quotient. And then, so that's the first thing. And then the next thing that we have to do is multiply. So we're going to take the first term of our quotient and we're going to multiply it by both terms of our dividend. So x times by x, that's going to give me x squared. And then x times by negative 4 is going to give me negative 4x. And I'm going to write them. So whenever I do multiply the first term here with these terms, I'm going to write them underneath the terms of the dividend. And then we are going to subtract. Now, this is the product that we got, and we're going to subtract the whole thing. So we're going to subtract. Now, whenever I do that, that's going to multiply. Since I'm subtracting the entire polynomial, remember that whenever you subtract a polynomial, you have to distribute the negative to the terms that are inside. And so to kind of make that a little bit shorter, that process a little bit quicker, what I do is I just take the terms that I already have, and then I just flip the signs of what I have inside. So like that. And then I add these terms together. So I get x squared minus x squared. That's going to cancel and give me nothing right here. And then I have x plus 4x, and I can add those together to give me plus 5x. So the process is to divide the first terms to get this term, and then I multiply this term here. So divide, multiply, and I get this right here, and then I subtract. So divide, multiply, subtract. Those are the first three things we have to do. Next thing is to bring down remaining terms. So notice that we didn't use this negative 17 here, so we're going to bring it down. So make that negative 17, and then we're going to repeat the process. So we're going to start over and do the exact same thing. So we're going to start with this term and this term, and we're going to divide them. So I'm going to take 5x divided by x, and that's just going to give me 5. And I'm going to write that up here as plus 5. So I divide. Next thing I need to do is multiply. So 5 times by x, that's going to give me 5x. I'm going to write it underneath these terms here. And then 5 times by negative 4, that's going to give me minus 20. So first I divided, and I got this right here. And then I multiply, and I get this right here. And now I'm going to subtract. And to subtract, I'm going to change flip the signs of the terms that I have, and then I'm going to add these together. So 5x and negative 5x, those cancel. 20 and negative 17 gives me positive 3. And there's nothing left to bring down. And also, if I try to divide 3 over x, well, that doesn't give me, I don't want 3 over x. That's not a polynomial. That's not something that I can really work with, I guess you could say. So we've come to the point where we found our remainder. This is our remainder. So we just need to write our answer. So we have an answer to this division problem. It's going to be equal to x plus 5. And then to write the remainder, we're going to say plus 3 over x minus 4. So we are dividing by x minus 4, and we get x plus 5. But then we get the remainder, and we put the remainder over what we're dividing by, the divisor. And there you go. We have our answer right there. Let's try another one. So again, I'm going to set this up where I have the divisor, or the dividend rather, x cubed plus x squared plus x plus 2, and then I'm going to write x squared plus 0x minus 1. So this right here is called a placeholder, and I like using placeholders because it makes certain that I can line up like terms here. So the whole point whenever we multiply these terms over here is that we line them up with the correct terms here to add them. So the reason why I like to use a placeholder is that if I do that, I'm going to line up like terms. So cubed terms, squared terms, regular terms, and constants. And I want to make sure that I do that so I don't make a mistake in adding terms that aren't alike. And then let's go through the process. So the first thing I want to do is divide. So I'm going to take the first term here of the dividend and divide it by the first term of the divisor. So x to the third divided by x squared, that's going to give me x. And I'm going to put that up here. So the first is to divide, then to multiply. I'm going to take this and multiply it by all the terms over here. So x times by x squared is going to give me x to the third. And then when I multiply x by 0x, that's going to be 0. But I'm going to write it as plus 0x squared. And the only reason why this is here, even though this just means 0, is that whenever I add, I'm going to have these like terms line up. I want terms to be lined up. Making mistakes. Okay, and then then x times by negative 1, that's going to give me negative x. Okay, so we divided, we multiplied, and now we're going to subtract. So I'm going to flip the signs. It doesn't really matter here because you can't really add or subtract 0, but just to be consistent, and then that's going to be plus, and then I'm going to add these together. So I get x to the third minus x cubed, that's 0. And I get 1x squared minus 0x squared, that's still just going to be x squared. And then plus x, that's going to be plus 2x. So I divided, I multiplied, subtracted. Next is to bring down any terms that I didn't use, so that's this plus 2 right here. So I'm going to bring that down. And I'm going to repeat the process. So x squared divided by x squared. That's going to be equal to 1. So I'm going to put that right here as plus 1, and then I'm going to multiply. Well, if I multiply 1 by this polynomial, it's going to be x squared plus 0x minus 1. So I divided those. I got 1. I'm going to multiply, and I get this right here. And now I'm going to subtract, so I'm going to flip the signs of everything here. And then do the math here, combine like terms, those are going to go. That's going to leave me with plus 2x, and then plus 3. Okay? And then at this point, we're good. We don't need to go any further. I'm already at my constant right here, so any term that adds on to this is going to be the remainder, and that this right here is our remainder. You can also try to divide, so whenever I take 2x divided by x squared, 2x over x squared, notice that the degree of the numerator is 1 and the degree of the denominator is 2, so that's when I've reached my remainder, whenever that happens. Okay, and so my answer is going to be x plus 1 plus the remainder over the divisor. So that's x squared minus 1. And yeah, there you go. Let's try another one here. So we have, let's write the dividend. That's going to be 5x to the 4th minus 2x cubed minus 7x squared plus 0x. So there's a placeholder there, minus 39. So if you want to, so placeholder, I have degree 4, 3, 2, 1, and 0. So because this doesn't have a degree 1 in here, I'm going to put 0x as its degree 1, even though that just means 0. And then for the divisor, we have x squared plus 2x minus 4. Okay, process is divide, so I take that and divide it by that. So I'm going to do 5x to the 4th divided by x squared. That's going to be equal to 5x squared. So put that up here, 5x squared. I'm going to take this, I'm going to multiply by all these terms over here. So 5x squared times x squared is going to be 5x to the 4th. And then 5x squared times by 2x, that's going to be plus 10x cubed. And then minus 20x squared. And then I'm going to subtract, meaning I'm going to flip all the signs here. Okay, those are going to cancel. And then I'm going to get minus 12x cubed. And then plus 13x squared. And then I'm going to bring down the unused terms. So plus 0x minus 39. And I'm going to repeat the process. So this time I'm going to do negative 12x cubed divided by x squared. So this leading term divided by the leading term here, and that's going to give me negative 12x. So minus 12x, and I'm going to take this and multiply it by all these terms here. So that's going to give me negative 12x cubed minus 24x squared. And then plus 48x, right? Plus 48x, I believe. That should be good. Okay. Got calculator ready. So, and then I'm going to subtract. So I'm going to flip the signs. I like to do this in red. So that's going to be plus, that's going to be plus, and this is going to be minus. Okay. So when I do this, that's going to cancel. And then I'm going to get positive 24 plus 13, and that's going to give me 37x squared. Okay, and then that's going to give me negative 48x, and then I'm going to bring this term down, so minus 39, and then repeat the process. I'm going to do 37x squared divided by x squared. That's going to give me 37, so plus 37, and then I'm going to take that and multiply it by all these terms here. That's going to give me 37x squared, and then 37 times by 2 is going to give me positive 74x, and 37 times by 4 is going to give me negative 148. Okay, and then I'm going to subtract, so I'm going to change all the signs here. Those are going to cancel. And then we're going to get negative 48 minus 74. That's going to give me negative 122. And then 148 minus 39. That's going to give me plus, oh, that's got to be x right there. And then plus 109 right there. And we have found our remainder. And it doesn't look pretty, but hopefully that's right. But our answer is going to be 5x squared minus 12x plus 37 Then you can do plus negative 122x plus 109 all over x squared plus 2x minus 4. And there you go. Okay, the next problems here are going to be using synthetic division, which is nice. Synthetic division is pretty easy. So to set up synthetic division, I'm going to make a box here, and the number that goes for this box is going to be what makes this 0. So what is going to make x minus 4 0 is if x is equal to 4. And then I'm going to write down the coefficients of the polynomial. So it's going to be 1, 8, and 1. And then I'm going to bring down the first coefficient below the line here that I just made. And then what I'm going to do is I'm going to multiply 1 by 4, which is going to give me 4, and I put that in between the line and the next coefficient. I'm going to add these together, so 8 and 4 is going to give me 12, and then I'm going to repeat the process. I'm going to do 12 times by 4. That's going to give me 36. Nope, that's going to give me 48. And then I'm going to add these together. That's going to give me 49. And then I have my answer. I just have to write it accordingly. So if this is of degree 2, whatever degree this is, your answer is going to be 1 less. So this is degree 2. This polynomial written here is going to be of degree 1, and this is the leading term. This is the coefficient of the leading term. So my polynomial is going to be 1x plus 12. This is the remainder. So then plus 49 over x minus 4. So again, this is of degree 2. These are the coefficients of my dividend. These are the coefficients of my quotient. Okay, and so here, these are the coefficients of my quotient, and the quotient is going to be 1 degree less than the dividend. So this is 2. This is going to be degree 1, and this is its leading coefficient. So then we're going to have 1x plus 12. We're just going to write, it's in standard form. So degree 1, then this isn't going to have an x, and this is going to be the remainder. Let's try another one. So we have 2x squared minus x plus 7. So first of all, let's think about what we're going to have in the box here. We're going to put the number that makes this 0. So that has to be negative 5. And then the coefficients of our dividend are 2, negative 1, and 7. I'm going to put a line right here. And then I'm going to put the 2 below the line, so 2. I'm going to take the number here and multiply it here. That's going to give me negative 10. I'm going to combine terms here. That's going to give me negative 11. Negative 11 times by negative 5 is going to be positive 55. And then we got 55 plus 7, and that's going to give me 62. So these are the coefficients of my coefficients of my quotient, and this is the coefficient, the leading coefficient, and the leading coefficient has to be degree 1 because the degree here has to be 1 because the degree here is 2. So it's going to be 2x minus 11, and then the last number here is the remainder, so 62 over x plus 5. Okay, so I think we're doing pretty good here. Now the next one, we have to be careful because we're going to need a placeholder. So we're going to need a placeholder. So first of all, the box number that we're going to use is 3 because that's what's going to make that equal to 0. Okay. And then we're going to use the coefficients here, but notice that this doesn't have a middle term. Okay. So it doesn't have a middle term. So the coefficients are 1, 0 for that middle term, and then 9. And we're going to drop the 1, and the 1 is going to be multiplied by the 3 in the box number. Okay, so 1 by 3, that's going to give me 3. We're going to combine the terms here, and that's going to give me 3. And 3 times 3, that's going to give me 9. And that's going to give me 18. Okay, and then this is the coefficient of my leading term of my quotient, and that's going to just be x. So this is going to be 1x, and then this has to be to the first degree since the dividend was of the second degree. So 1x plus 3, and then the remainder is going to be 18 over x minus 3. Okay. Okay, let's move on to the next one. So for 7, so that's a big polynomial there. We're just going to have a lot of leading coefficients is all, so that shouldn't be too bad. Okay, so the box number has to be 6, since that's what's going to make that the divisors 0. And then we have 1, -5, -8, 13, and -12. And we don't need a placeholder here. We got 4, 3, 2, 1, 0. So we have all terms that we need. Okay, and then draw the line here, bring down the 1. 1 times by 6 is going to be 6. We're going to combine the terms there. That's going to give me 1. And then again, 1 times by 6 is going to give me 6. Combine the terms there. That's going to give me -2. And then -2 times by 6 is going to give me -12. Combine the terms there. That's going to give me 1. 1 times by 6 is going to give me 6 again. And then that's going to give me -6. Okay? So this is going to be x to the third. This is the leading coefficient that's here, so 1x to the third, and it has to be degree 3 because this is degree 4, and then we're just going to go down. Plus x squared, 1x squared, minus 2x, and then it's going to be plus 1, then minus, we'll just say plus -6 over x minus 6. Okay. I think that should be good right there. Let me just look over the work that I did for these other ones, make sure that I didn't make any mistakes. Okay, I think we're looking pretty good. Okay, so that's synthetic. I think we're just going to use more synthetic division down here. So use synthetic division to evaluate the function. Okay. Yeah. To evaluate the function. Okay, yeah, no, I see what we're doing here. So here's what we're going to do. We're basically just doing the same thing that we did before, but our answer, we're going to write our answer differently. And so let me explain what I mean by that. So it's given us that x is equal to -1. So it's giving us the box number. So what's going to make the dividend, the divisor 0? So we're going to use -1 as the box number. So we don't have to change the sign. So don't change the sign there. It's giving us what the box number is going to be. Up here, it's very different. It's we have to find what number is going to make that 0. Here, it's telling us what it is. So -1, and then we're going to write the coefficients. So -1, -8, and 30. And then, so we're going to drop the -1. We're going to multiply the two numbers here. That's going to be -1 times -1, +1. We're going to combine the terms that we have there. So -7, multiply. That's going to give me +7. And then 37 is going to be what I put there. So I don't need to write the quotient, but essentially we have another way of evaluating the function at the given value of x. So pretty much if I plug in -1 into my function, I'm going to get 37. This is what the remainder is. The remainder tells me what I'm going to get if I were to plug this number into the function. So if I plug in -1 in here, I am going to get 37. We can try it out. So if I plug in -1 here, so negative 1 squared minus 8 times by negative 1 plus 30. This becomes negative 1 because negative 1 squared is positive 1. That's going to change to positive 8 and plus 30. This combines to be 7 plus 30, and that gives me 37, which is the same thing as my remainder. So it's just a kind of a cool it's kind of a cool way to evaluate a function without using a calculator. If you don't have a calculator, then one thing that you could do is, instead of plugging it in, you can just do some arithmetic and get the remainder, which is going to be the same thing as the output. So if I go back up here, we can apply the same concept. So if I plug in 4 into the function here, I'm going to get 49. If I plug in negative 5 here and do the math, I'm going to get 62. If I plug in 3 right here, well, think about it. 3 squared is going to be 9, plus 9, that gives me 18. If I plug into 6 into all of these right here, I'm going to get negative 6. So that's essentially another way of, it's just just kind of a cool thing about synthetic division. Okay, so here we're going to plug in 2. We're going to have 1, negative 2, 4, and 3. We're going to drop the 1. 1 times by 2 is 2. 2 and negative 2 combined together is 0. 0 times 2 is going to be 0. 4 and 0 added together is 4. Then 8, and then we get 11. So we'll say f of 2 is equal to 11. And there you go. Okay, let's try 10. So we're going to use 6. We're going to have 1, 0, negative 6, and 1. The 0 is going to be the placeholder for the x squared term. And then drop the 1. 1 times by 6 is 6. Combine those terms. That's still going to be 6. 6 times 6 is 36. Combine the terms. That's going to give me 30. And then 30 times by 6, that's going to give me 180. 180, and then add the 1. That's going to give me 181. So f of 6 is equal to 181. Okay, and then last but not least, we have the 3. We have 1, 0, 6, negative 7, and 1. The 0 is for the placeholder of the x cubed term. Drop the 1. 1 times by 3 is 3. Add those together. We get 3. 3 times 3 is 9. 9 and 6 added together is 15. 15 times 3 is going to be 45. 45 minus 7, that's going to be 38. And 38 times by 3 is going to be 114. Let's see. And then that's going to get, just making sure I'm doing that right, and 115. So f of 3 is going to be equal to 115. And there you go. So that's everything for this homework assignment.